Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 4 from the October 2024 Pure Mathematics P4 paper from the International A-Level Edexcel exam. And here we have a sketch of a curve, very strange type of curve here. C with the equation 3x squared plus 2y squared minus 4xy plus 8 to the power of x minus 11 is equal to 0. The point P has coordinates 1, 2. Okay, and we got to verify that P lies on C. Okay, so we got to verify that this point here lies on this curve. So what we can do is we can basically just think about when a point lies on a curve, it satisfies the equation of the curve. So the point 1, 2. So if P is on the curve C, then the points 1, 2 satisfy its equation. Satisfy its equation. And how do we prove that? Well, we substitute the point 1, 2 into the equation, and we verify that it gives us 0. So we have 3 times 1 squared plus 2 times 2 squared minus 4 times 1 times 2 plus 8 to the power of 1 minus 11. Now that's going to give us 3 plus 2 times 4, which is 8, minus 8, okay, plus 8 and minus 11. So 8 minus 8 is 0, 3 plus 8 is equal to 11, and 11 minus 11 is equal to 0. Okay, so P lies, therefore P lies on C. Okay, and that's it, because this whole thing equals the equation. When you put x equals 1, y equals 2 in here, this side becomes 0, which is, that side is 0, so the equation is satisfied. All right, part B says find dy dx in terms of x and y. Find dy dx in terms of x and y. All right, so now we're going to do that. So let's continue. So we have to find dy dx. Now, this is going to be done by using what's called implicit differentiation. Many people get kind of confused and worried when they see something like this, and we have to find dy dx, and they think, oh, we have to make y the subject and then find dy dx. That would be finding dy dx in terms of just x then, if we made y the subject first. And making y the subject would be very difficult. Right? When you have a y squared term and a y term, and x, y's, and all of this stuff, it's going to be very difficult to do so. So we have to go back to the foundations of what differentiation is and try to understand that for us to be able to understand how to do what's called implicit differentiation. And we've been doing implicit differentiation right from the start of differentiation, but we just didn't think of it in that way, right? So we had, for example, y equals, say, 4x squared minus 3x plus 2. And we just said, okay, we got to differentiate this, so we had to find dy dx. So we used to write down dy dx equals 8x minus 3. And there's absolutely nothing wrong with that. However, there's a few hidden steps that will help us understand what implicit differentiation is before we get there. First thing is that what we do to one side of the equation, we do the same thing to the other side. So what we're going to do here is we're going to differentiate this side with respect to x. So this side has got a y there, so you're going to find the differential of y with respect to x. And we're going to differentiate the whole of this side also with respect to x. So you have 4x squared minus 3x plus 2. Differentiate that with respect to x. Okay, so when you differentiate y with respect to x, you get dy dx. Okay, you get dy dx. Basically, you have y inside a function to the power of 1. So you multiply by the power, that gives you 1 times y to the power of 0. Okay, and then because y is some function of x, y can be expressed in terms of x eventually, right? Y is some function of x. it's like you have the chain rule to apply to it. So you got to differentiate what y is with respect to x. So that's going to give you dy dx. If you differentiate y with respect to x, you get dy dx. And so basically now you end up with just dy dx. That's basically one way of thinking about it. And that will come into play later on when we're doing some of these other terms. All right. So that's how you differentiate y with respect to x. You get dy dx. Okay. Now, that kind of sounds obvious, but you'll see what I mean later on. Okay. And now we have these terms here, which are separate terms. With differentiation and integration, we can differentiate each term individually. So I'm going to differentiate x squared with respect to x, and I'm going to differentiate 3x with respect to x, and I'm going to differentiate 2, the constant, with respect to x. So this gives me 8x, this gives me minus 3, and this gives me 0. So we end up with dy dx equals 8x minus 3. Now we don't need to worry about any of these two lines when we're doing something simple like this. Okay, it's just this first, and then this is the answer, and that's perfectly fine. We don't even think about all of this. But this is kind of what's going on in the background. This is like the basis behind what we're doing. And this will help us understand what to do when we differentiate something like this. Okay, it's very important for us to understand that. Okay, so now we're going to basically differentiate each of these terms with respect to x. So if I differentiate 3x squared with respect to x, I get 6x. If I differentiate 2y squared with respect to x, I get 2 times 2, which is 4y to the power of 1. Now, because I have a y term there, it's like you got a function inside the function. You have to multiply, because of the chain rule, by the differential of y, which is dy dx. It's like you have 2 times a function inside the function. The main function is something squared. So you multiply by the power. So when you differentiate, you multiply by the power, you get 4. This stays as it is, and you put to the power of 1, and then you multiply by the differential of what's inside the function. What's the differential of y? dy dx. That's what's going on here. So you get 4y to the power of 1 times dy dx. So basically, even if you didn't understand that, whenever you differentiate a y term with respect to x, you just put times dy dx after you differentiate it like as normal. Then you have minus 4 times, and now I have a product of 2 separate functions. X, y is like a product of 2 functions. I'm going to get rid of all of this stuff here because it's not really part of the question. I just need some space. That was just a bit of an explanation. Okay, so now, this is also a bit of an explanation, but it's related to this. Okay, now we want to differentiate this with respect to x. Let me just move this across a bit. Okay, so I've got x times y. I've got x times y. Okay, I've just kept the minus 4 separate. I like to do that because especially when there's a minus sign. So I've got this product of 2 separate functions which are both in terms, or they are both functions of x. So I'm going to call u x and I'm going to call v y. So u dash is 1 and v dash is 1 times dy dx. Be very careful because you differentiate y with respect to x, it's going to give you 1 times dy dx. So we're going to multiply these two together. So we have 1 times y, which is y, plus these two multiplied, which is x dy dx. And then minus 11 when you differentiate becomes 0. And of course 0, if you differentiate 0, you get 0 as well. So any constant when you differentiate becomes 0. So this is what we're left with. Okay, so we have 6x plus 4y dy dx minus 4y and minus, I forgot something. Let's just put that back again. Be very careful. Plus 8x. Now when you differentiate 8 to the power of x, 8 to the power of x, you get 8 to the power of x times ln 8. The differential of 8 to the power of x with respect to x is 8 to the power of x times ln 8. That's one of the standard results that we should know. I must have messed up there, I forgot that. Right, and minus 11 becomes 0. And this side, of course, you differentiate 0, you get 0. So now we can expand this. We have 6x plus 4y dy dx minus 4y minus 4x dy dx plus 8 to the power of x ln 8 is equal to 0. So we have to find what dy dx is in terms of x and y. So I'm going to keep the dy dx terms on one side of this equation. So 4y minus 4x dy 4y dy dx plus minus 4x dy dx is equal to, now what I'll do is, in fact, you know what I'm going to do to make it look neat in the end? I'm going to do the other way around. I'm going to say on this side I'll have 4x dy dx. I added that to both sides and subtract this minus 4y. Minus 4y dy dx on this side, and on this side I have 6x minus 4y plus 8 to the power of x ln 8. Otherwise I'd have made all of them would have minus in front of them. It would look a bit messy. And now I can take out dy dx as a common factor on these two terms. So I've got 4x minus 4y equals 6x minus 4y plus 8 to the power of x ln 8. Okay, and then I can just divide by 4x minus 4y. So in the end, dy dx is going to be all of this, 6x minus 4y plus 8 to the power of x ln 8 over 4x minus 4y. Okay, and there we have our final answer. Okay, that's dy dx. A bit long-winded, we've got that at the end. Okay, there's 8 to the power of x ln 8. Okay, so that's dy dx in terms of x and y. So that's part B of this question. Okay, I think I'll need this. Okay, now for part C, we're told that the normal to curve, let me just paste this down here so in case I need it, which I'm pretty sure I will. Okay, so it says the normal to C at P crosses the x-axis at a point Q. Find the x-coordinate of Q, giving your answer in the form a plus b ln 2, where a and b are integers. Okay, so the normal to a curve is a line which is at right angles to the tangent to the curve. The tangent to curve would look something like this here. Right? It would touch the curve at P and share the same gradient as P, of the curve at P. The normal is a line which cuts the curve or cuts the tangent in at 90 degrees at the same point on the curve where the tangent hits the curve. So this is the normal, and we want to find where the normal and the x-axis where they meet. We need to find this point, the x-coordinate of Q. Of course, the y-coordinate of Q is 0. So we want to find the x-coordinate of that point Q where these two curves intersect. All right, that's what we're trying to find here. All right, so what we need to do basically is we need to start to find the equation of the normal to the curve. Okay, this is the tangent, this is the normal. So the first thing we need to do is to find the gradient of the tangent. If I find the gradient of the tangent, then I can find the gradient of the normal because they're perpendicular. The gradient of the tangent times the gradient of the normal is going to give you -1. Okay, so we can use dy dx. We know that the gradient function is dy dx. So dy dx is equal to 6x minus 4y plus 8 to the power of x ln 8 over 4x minus 4y. Okay, over 4x minus 4y. So we can put the point 1, 2. 1, 2. That's the point P. We were given its coordinates as 1, 2. We can put those values into the gradient function, and that will be the gradient of the tangent. Okay, so 6 times 1 minus 4 times 2 plus 8 to the power of 1 times ln 8 over 4x minus 4y, which is going to be 4 minus 8. Okay, so this will give us what? You're going to have 6 minus 8 plus 8 ln 8. So 6 minus 8 is minus 2 plus 8 ln 8 over negative 4. Okay, so that's the gradient of the tangent in its exact form, which we want to keep in this form. I can simplify a little bit. For example, I can take out 2. I'll have minus 1 plus 4 ln 8 over minus 4. So I can cancel that out. So I'll have minus 1 plus 4 ln 8 over negative 2. So that's the gradient of the tangent. Okay, now what we can do is we can rewrite this to make it a bit simpler to deal with as 4 ln 8 minus 1 over negative 2. Okay. Yeah, we could do that. And now what we can do is we need the equation or the gradient of the normal. Okay, because we want to find where the normal hits the x-axis. This is the gradient for the tangent. So for us to deal with the normal, we have to find the negative reciprocal of this, because we know that the gradient of the tangent times the gradient of the normal gives you negative 1. All right. So I need the negative reciprocal of this. So I need to turn this upside down. So the gradient of the normal is going to be the same thing turned upside down. So I'll have 4 times ln 8 minus 1, and we change the sign. So the minus it's become positive. Okay, so I've got 2 over 4 ln 8 minus 1. So I've changed the sign and I've turned it upside down. That's the gradient of the normal. And we know that the equation of a straight line is given by y minus y1 equals m times x minus x1. And x and y are the coordinates of the point, which is 1, 2. So you have y minus 2 equals m, which is, as we know here, 2 over 4 ln 8 minus 1 times x minus x1, which is x1 is 1. So we don't actually have to write down the equation of the straight line. We just have to know where it crosses the where it crosses the x-axis. Now it crosses the x-axis, okay, when y is equal to 0, because that's the coordinate of every point on the x-axis, y equals 0. In fact, this line is y equals 0. All right, y equals 0. So what we can do here is we can just replace the y with 0, and then when we find x, that will be the x coordinate where it hits the y-axis. So I'll put 0 minus 2 equals 2 over 4 ln 8 minus 1 times x minus 1. All right, so I'm going to multiply both sides by 4 ln 8 minus 1. So this is going to be minus 2 times 4 ln 8 minus 1. And divide both sides by 2. Okay, and that's equal to x plus x minus 1. So they cancel out, leaving with minus 1. So when I expand this, I'm going to get basically minus 4 ln 8 plus 1 equals x minus 1. So I'll end up with here, you can say 1 plus 1, which is 2, minus 4 ln 8 equals x. So now the question says give the answer in terms of a plus b ln 2. So it has to have a ln 2. I have a ln 8, so I have to rewrite this slightly. And I can write 8 as 2 to the power of 3. That's how it's related. So x is equal to 2 minus 4 times the ln of 2 to the power of 3. That's the same as ln 8. And I can use the power law. I'll have 3 times 4, which is 12. So I'm left with x equals 2 minus 12 times ln 2. All right, so that's what we got, a plus b ln 2. So we can say a is 2 and b is negative 12. Okay, so there's the answer in the form required. And that concludes this question. question number 4 from the October 2024 P4 paper. Other questions from this paper can be found in the playlist that will appear in the top right of the screen at the end of this video. Other questions from the topic of implicit differentiation, which this is related to, can be found in the playlist over here. You can subscribe to my channel by clicking on this link, and the video at the top here tells you how to use my channel to find what you're looking for efficiently. Thank you for watching, and see you soon.